Welcome everyone to Razorleaf's webinar series Unpacking 3D Experience. Today's topic is how eBOM transforms into mBOM and will be presented by Razorleaf's 3D Experience expert, Kip Speck. Kip has over 15 years in PLM and PDM industry, mainly focused on Dassault Systems PDM and PLM. He is a pre-sales architect with Razorleaf. Kip co-founded a reseller and worked for another, as well as this is his second term at Razorleaf. We will be sending the recording to all registrants within the next day or two. And if you have any questions during the webinar, please pop them in the chat and we'll answer them at the end of this presentation. And with that, I will turn things over to Kip Speck.
Thank you very much, Maggie. So let's go ahead and get started. This is a little bit of a long webinar today, but please stay tuned to the end. I think you'll really enjoy what I presented towards the end of this. So we'll get going here. Welcome to today's session, Unpacking 3D Experience, how eBOM transforms to mBOM. For today's webinar agenda, we'll talk a little bit about Razorleaf. We'll talk about the relationship between eBOM and mBOM, a look at the eBOM, the engineering definition, a look at the mBOM manufacturing definition, and how the eBOM transitions to the mBOM, and we'll also look at product definition and how that affects the eBOM and mBOM. Razorleaf professional service offerings. At Razorleaf, our business is servicing and supporting customers. We are vendor agnostic, and we have over 20 years experience in PLM, PDM, and the entire scope of implementing, supporting, and growing our customers' enterprise solution. At Razorleaf, we specialize in implementations by defining clear, measurable goals, mitigate risk, and assign talent and resources to drive success. Migrations with guaranteed accuracy, by mapping out our data requirements, preventing data gaps, troubleshooting missing data, and rigorous validation, planning, and testing. Our support and training for customers is our first class with help desk, hourly contract, or subscriptions and support of all phases of implementations while providing key metrics. Razorleaf ensures you have the skill available with staff augmentation to your internal team and to accelerate your projects. Additionally, Razorleaf provides test automation with detailed success plans, installing the test automation software for PLM upgrades, customizations, and continuous training and testing for validation. In today's dynamic and highly competitive product development landscape, the ability to seamlessly translate engineering intent into manufacturing reality is no longer a luxury. It's a necessity. As products become more complex, customized, and globally sourced, ensuring tight alignment between the engineering bill of materials, the eBOM, and the manufacturing bill of materials, the mBOM, becomes critical. This alignment is what enables organizations to uphold product quality, optimize production costs, and accelerate time to market, all while managing ever-evolving customer requirements and compliance demands. A disconnect at this critical handoff between design and execution can result in costly delays, rework, and even product failures. That's why understanding and managing the relationship between eBOM and mBOM is essential for any organization striving to achieve operational excellence. Let's review the eBOM and the role it plays in the engineering definition. For today's webinar, I used the engineering release role XEN. In this session, we'll explore the fundamental roles of eBOM and mBOM, examine how configurations and collaboration across engineering and manufacturing teams shape them. The eBOM includes CAD models, design specifications, attributes, and revision components to meet performance, compliance, and system behavior. It answers the question, what components make up the product and their intended functionality? There are two main concepts we will use today, the 150% eBOM and the 100% eBOM. The primary process for product development, products and their configurations, which are typically driven by marketing, sales, or customer demand, are defined. Engineering defines the components and specifications to meet the product definitions and their variants of product, the 150% eBOM. Using the PLM tools and methods, the 150% eBOM is filtered to the 100% variant-specific eBOM. Manufacturing uses this 100% eBOM to drive the configuration-specific mBOM. Here we see the 150% eBOM definition defined by engineering. We are using the engineering release app in 3DX. The root node was defined by engineering. Engineering also created child nodes to organize the structure by categories. Engineering then created the components, 3D models, 2D drawings, specifications, etc. Now let's look at the 100% engineering bill of materials. Note that the product definition, model version, XLTA, and the product configuration, XLT 5.4 Premium, have been applied. We also see the components of the 150% eBOM definition have been filtered to the configuration-specific definition. The drivetrain is specific to four-wheel drive. The engine is the 5.4 liter high output. The tech components are also filtered based on the configuration. So let's take a look at the engineering bill of materials in 3DEXPERIENCE. Note that I already have my root node opened, my XLT revision A. Inside of my engineering bill of material, I have my main categories: the drivetrain, the engine, and the technology. Now, engineering may decide to add whatever categories or separators or put a structure in place that makes sense to them in order for different areas to work on different components, maybe for security purposes. There's a whole host of reasons to separate the different sections of your bill of materials or your engineering definition structure in 3DEXPERIENCE. So beyond the scope of this, but for today's discussion, we'll take a look at what is included currently in this engineering definition. And right now, it's the 150% bill of materials. So I'm going to select it, and I'm going to go ahead and expand all so we can take a look. And I've already created all the components. Now, there aren't any CAD data to this or anything else. The only thing I've done is create a physical product structure, which you can do, and then you can add your CAD to it or open it up and start adding CAD whenever you need to. But for the demonstration today, for what we're looking at, the important part is the bill of materials or the engineering definition structure. Now, as you see in drivetrain, I have a four-wheel drive, and I also have rear-wheel drive. Now, we know that the options or the variants and the configuration, this is filtered down based on what option is selected for the vehicle. Again, in the engine, there's the 5.4 liter and the 4.2 liter. And again, this is showing both options. So this is my 150% bill of materials. And then in the technology section, there's Wi-Fi antenna, the GPS, a standard GPS, a premium, a sound system, premium or base. And these aren't real things. These are just something I made up to show the structure and show how this is presented, right? So then the challenge then is how do I eventually get this, or how can I work on this as it's a 150% bill of material versus 150 and 100% bill of materials, or the filtered configured bill of materials. So we'll get into that a little bit later, but just to kind of navigate around a little bit, what you see at the top here, that's the instance, or that's my XLT is the name of the physical product. the physical product revision is Rev A. You see model version here, and that's going to be where we apply filters or configuration later on to be able to move this down to 100% bill of materials. But for right now, we'll go ahead and stop here, just to understand that there is structure here. Engineering can work on this however they want, create whatever categories you need, whatever components belong underneath it, and things like that. All right, so using the same bill of materials, my 150% bill of material or engineering definition, how do we filter it down to 100% BOM? Now, I'm going to show you how it's done, but behind the scenes, there's other things that have to be done. So the way you filter it is if I select my model, my physical product at the top here, my root node, I select the model version link here. What it allows me to do is to search for the model version that's created in the product definition. So I'm going to go ahead and select that one that I've defined. Now it's going to apply that as my the link to my product definition, right? So I'll go ahead and do an expand all, so just so you can see that the structure is still there. It still has everything that was part of it, right? So all of the options are still there at the product config at the model version definition. Now I'm going to go ahead and select the product configuration, and when I select it, my product configuration, I'll go ahead and select OK, and OK here. Now I'm going to go ahead and do expand all again and watch what happens. So I'll do expand all, and now notice that it is filtered. My engineering definition is filtered to this model version, XLTA, and this configuration. So the only thing I've done is apply the model version and configuration specifically to my engineering definition, and it has filtered out the components that's applied to it. Now I understand you're going to go, well, how did you get there? Well, we'll get there. We'll talk about that in a little bit. And there's a key component to what I did in this scenario. I used product definition, so the product architect, to create a model version, the variability, and the configurations so that I could apply those to my engineering definition, and then that also in turn applies to my manufacturing. However, I'll get to that in a little bit, but just understand this is what we're driving towards. We're driving towards the engineering definition that is 150% with all variants, and then be able to configure it or filter it based on the product configurations. Let's take a quick look at the 𝘼𝘆𝑚 and the role it plays in the manufacturing definition. For today's webinar, I used the Manufacturing Items Manager, the MFN. The 𝘼𝘆𝑚 is derived from the 100% eBOM engineering definition. However, it is tailored to how the product will be built. It answers the question, what is needed to build the product in production environment? What are the sequences required, and what are the constraints? This includes all components, consumables, fasteners, fixtures, jigs, and consumables. The manufacturing process also requires specific groupings. Additional considerations are given to plants, the plant capacity, capabilities, multi-step processes, and intermediate packaging. Further, manufacturing considers any regulatory requirements for the plants. How the 𝘼𝘆𝑚 works. Once engineering definition, the eBOM is finalized or is in a state for manufacturing to begin review and planning, the manufacturing definition, 𝘼𝑚, is created by manufacturing engineering to reflect the product will be built. The 𝘼𝑚 integrates the engineering intent, the manufacturing constraints, operational logistics, non-engineering materials, and supplier-specific parts. Here we see the manufacturing BOM, the 𝘼𝘆𝑚. At the root is a manufacturing assembly. That will be the root for this build. The manufacturing subassemblies are also created as manufacturing assemblies to consume the engineering definition components such as the drivetrain, the front axle, drive shaft, engine and entertainment system. Manufacturing kits are also added for components such as U-bolt nuts, engine mount bolts, and the GPS components. Manufacturing will also add the provided parts that are from the engineering definition. So let's take a look at our manufacturing definition, or our 𝘼𝘆𝑚, or manufacturing bill of materials. And what you'll notice is that I've already created the structure, I've defined everything, brought all the components in and things like that. So this is kind of the end result. We'll take a look at a little bit more of it here in a minute, but and how it specifically relates to the engineering 100% bill of materials here a little bit later. But understand what the manufacturing structure looks like, and you'll notice that at the top level I have the specific configuration that is going to be built. In the top level is a manufacturing assembly. Now I've added in the other components, the other categories or different areas, and these may be components or structures for manufacturing on how they need to assemble, build, or machine or process that component. So I might have a drivetrain and break these things down from engineering in a different order than what engineering has it, specific because I might have to put several components together, ship it over, be welded, primed, and other processes done. So I may need to group these in a different way than what engineering had them. So we can create manufacturing assemblies. We can create manufacturing kits for nuts, bolts, things like that. We may need to have those in different positions and things like that. I may need, for like the wheels, I need 6 lug nuts on each wheel. So I might need 4 kits, one for each wheel, right? So I can break these up into different areas, different kits and things like that. But the important part is that manufacturing does this in a way that supports the production of the item or the product, right? Things like tooling. I may have to put a tool in or a jig or something else, right, for welding components together. So there's a lot of other manufacturing components that I can add to this. In this one, I'm just showing provided parts, manufacturing assemblies, and manufacturing kits. Now you'll notice that there's a scope here. And what this scope is saying is that this manufacturing item has a scope link to the XLT version A, and it implements different items from that engineering definition or that product definition. Okay, the way we get to the manufacturing definition is from the 100% engineering definition through scope links and configurations and things like that. So anyway, so this is kind of what the manufacturing bill of materials is going to look like, and you can set this up or organize this based on how is needed to send this through production. All right, so let's kind of compare both the bill of material structures, so from engineering and manufacturing. But before I do, remember what we said is that the manufacturing definition comes from the 100% bill of material or engineering definition. So right now what I have open is the engineering view and the manufacturing view, right? So on the engineering side, what I want to be able to do is filter that down to the 100% bill of materials, because currently what I'm looking at is the engineering definition that is 150%. I know it because I see the 4-wheel drive, I see rear-wheel drive, I have both engines, things like that. So before I start scoping or planning my manufacturing definition, I need to get this down to the configuration of the product that I'm supposed to plan and build for. So I have this item selected in my engineering definition. I'm going to come down here and apply the filter, and it's showing me my configuration. So I'm going to select the configuration, XLT, and I'm going to select configurations. Now, there are times when you do manufacturing plan, but I'm not set up for that for this presentation, but there are ways to do this by the manufacturing plans as well. So in my configuration, I'm going to go ahead and select this premium. And I'm not going to consider all because then it would still show me everything. So I'm going to go ahead and say apply. And now when I come here and I'm going to say expand, expand all. Now you see that my engineering definition, even though I'm in the manufacturing items definition, I am looking at the engineering definition that is filtered to the specific configuration that I as manufacturing have to build. So it's the XLT 4-wheel drive 5.4 liter premium with the GPS and the sound system. Okay, so on the right hand side, my manufacturing definition is set up to look at this 100% bill of materials. And what you have to understand is there's what's called a scope link between the manufacturing definition and the engineering definition. So these scope links are, you can identify the scope, right, based on this little red item here. So you see scope. If I'll go ahead and drag this over. And I'll also drag over implements. Okay, so what it's telling me is that the scope link between this top level and engineering definition is the XLT configuration. Okay, so the XLT in this one, there's a scope link between the engineering definition and the manufacturing definition. So what I can see though is there's a manufacturing assembly that was added or created here for the structure. I'm going to go ahead and add in the column type so that you can see this is a manufacturing assembly. These are items that manufacturing created, and you'll notice the icon is slightly different between the manufacturing item and the engineering or the engineering definition item. So again, these manufacturing assemblies are created by manufacturing in order to group or provide grouping for different objects, right, in a way that is set up for production or manufacturing. Okay, but you'll see that this provided part, there's an instant, it's related here, and it's got a scope link back to that item. So if I select that object, I can actually look at the link between the two of them, the relationships between this object and this object. So if I do the nuts, you'll notice that there's a link between this one and this one. And it's telling me that the scope link or the implements this object from engineering. Now, the other part of that is to be able to see what is consumed from engineering into the manufacturing structure. So if I look at my BI essentials, I can see my assignment status between the engineering definition and the manufacturing definition. So now you'll notice that I've got colored dots here. These colored dots, the green says associated with scope. This one says assigned indirectly, right? So this one assigned indirectly. And this one, the front differential, is assigned directly. So when I look at this front diff, it's assigned here underneath the scope of the front diff, right? So there's a scope link from this directly to this, which means that this is assigned directly. Right, so now you can see the status of everything. If there was a yellow dot over here, then it would mean that it's not implemented, right? So then it wouldn't be it'll show that it's not implemented here. Now, if there was a revision to one of these, you'll notice that the revision of this one is Rev B, and you'll notice that in my manufacturing definition, I have a Rev B of my engineering scope here, right? So this specific manufacturing provided part is scoped to Rev B of this one. So if there's a Rev C, I would see a notification that this is out of sync. It's not up to date with the latest Rev. Now let's review the eBOM and the 𝘼𝘆𝑚. The relationship supports the digital thread, applies configuration and change governance across the product life cycles, drives cost-effective and high-quality manufacturing. Without the relationship, there is misalignment and introduces errors, rework, and delays that drive up costs and lost opportunities. Some key differences in the eBOM and 𝑚BOM for collaboration and integration. Collaboration and integration, the purpose of the eBOM is to capture design intent. The purpose of the 𝑚BOM is to support manufacturing execution. The owner of the eBOM is the engineering team, and the owner of the 𝑚BOM is manufacturing industrial engineering. The level of detail in the eBOM is at design level may omit things like fasteners, tools, consumables, things like that. 𝑚BOM is shop floor ready. It includes every item needed to produce it. The structure for eBOM is logical and product centric. The 𝑚BOM is process and operations centric. The tools used, eBOM uses CAD and PLM system. 𝑚BOM typically uses ERP, MES, and PLM systems. Some key differences in the eBOM and 𝑚BOM for configurability and variability. The configuration element, optional components, and the impact on the eBOM is that things like sunroof is only in some configurations. Variant assemblies. In eBOM, there's multiple versions of assemblies. The modular design means that its plug-and-play components drive modular eBOMs. Localization, things like country-specific, compliance of parts and materials, and customer-specific features. eBOM includes conditional logic or rules. The configuration rules are in the PLM system. The effectivity is driven by date, serial number, revision, plant, or option-based. The 150% eBOM is the master eBOM with all possible variants. So let's take a look at products and product configurations. Product configurations define the variants and options are available and which rules may be applied. Configurations are aligned with customer choices and market demands and potentially regulatory requirements. Let's review the product definition and the role it plays in the engineering and manufacturing BOM definitions. For today's webinar, I use 3D Product Architect role, the PAU. In 3DEXPERIENCE, you create a model version, shown here as XLTA. You then create the variability, such as variants and options. Variants are single selection items like an engine. You either select a 5.4 or a 4.6. You could not select both. Options are multi-selection. Like in technology group, you can select the type of GPS and the type of sound system and if Wi-Fi is included. Here is where you define what variants and options are available for this model version. If at a later time, say mid-year, there's a new option added, you could create a new model version, version B, and add or remove specific items to that model version. For example, auto manufacturers have mid-year updates where they may add a new color or interior options, or for this they create new model versions and make those available. Once you define the variability, you create configurations of the model version. In this case, model version XLT version A. Configuration XLT 5.4 Premium. Here I created a base configuration which has items that will be included for all, and I created a product configuration which includes all the available choices. As you see here, all variants are available at the base configuration. And for the product configuration, only the specific variants and options are allowed for that configuration, such as the engine and drivetrain. Here we use 3D Product Architect role to build the product structure and apply the variants and options to the physical products. The root has the configuration context of model XLT. So for the drivetrain node, The configuration context XLT states the model the current evolution specifies to use the model XLT model version. The four-wheel drive node inherits the context and applies the XLT drive four-wheel drive option. The rear-wheel drive does the same. So with the configuration context XLTA, if four-wheel drive is selected, rear-wheel drive is not available. Here we use 3D Product Architect role to build the product structure and apply the variants and options to the physical products. This shows the product structure filtered by the configuration XLT 5.4 liter four-wheel drive premium. Let's put it all together. All right, so let's put it all in action. So here I have my model version XLTA. These are my current variability and options that I have defined. So I want to add a new trim package. And that trim package I'm going to call the ST line. So in order to do that, I need to open up the trim packages. I'm going to create a new value. And that's going to be the name of the trim package. Now, I've created that trim package, but I need to be able to assign that value to the options. So when I look at trim packages, here I don't see the ST line available yet. The reason is I have to now assign the value to that group, to this variant option. The reason is I may only want the ST line available for the next model version. So maybe mid-year is when I want the ST line available. So I'd create a model version B, and then in model version B, I would assign the value of ST line so that that from model version B forward, it would have ST line, whereas model version A would not have it. Okay. So, but for right now, I'm just going to go ahead and apply it to model version A. To do that, I have to assign the value. So now that I see ST line here, I can go ahead and click the button that says add the value as an option in the trim packages. So now that I've created the variability under trim packages with the value of ST line, now I want to go ahead and create a configuration. So I want to create a base configuration first and then a product configuration. So I'm going to come over and say add base configuration. And we're going to call it the ST line. Okay, go ahead and create the base. Now, if I look at this Platinum All base as an example, you'll see that which options are available for that. So I'm going to do the same thing for ST line. And you'll notice it's telling me there's an issue because something has to be selected. So I'm going to say that it's always going to be a 5.4 liter. That one's not available. And it's going to be rear wheel drive, so this is not available. And rear wheel drive is selected. Additionally, I'm going to go ahead and select the ST line. It will always be selected. And then these are down here are optional, but I'm going to go ahead and say that when you select the ST line, you get the B&O system, you get Wi-Fi, and you get the premium GPS. So I'm going to go ahead and save that. And this is my base configuration. So now let's go through and we need to create a product configuration from here. So I'm going to say new product configuration, and I'm going to call it ST line 5.4 rear wheel drive premium. Okay. And it's going to be based off of the ST line. Now, it is valid because I've already made choices for it already. So, but I want to go through and I want to view what options are selected for this one. So right now, I want to edit this. I want to say it's the Triton Notice that there's locks by these, so it's going to be the 5.4 liter rear-wheel drive ST line, and these are my options. They're already selected, okay? Because I did it on the base. So there isn't many different options that you can choose when you choose this line of vehicle, okay? So again, let's look at the Platinum, and we'll see that these are the options that are previously selected, and the ST line, these are the options already selected, okay? So we've created a product configuration, we've created variability, we've added the line, the trim level, the ST line, and then we created a product configuration. So now let's go through and let's look at the product structure. So if I look at a XLT, my base of everything is based off of the XLT. If I come over and let's just refresh my screen, right? So I don't see my my new trim package, okay? So I'm going to go ahead and insert a new physical product into my product structure. I'm going to call it the ST line trim, just to keep my naming conventions consistent. Okay. Now, as you'll notice, I don't have a variant option applied to this yet. So if I go to my configuration, I can come over here and I can say edit variant effectivity. So I come over here and select ST line and choose and put a check mark there, and I select OK. Now I have this option available under the XLT version from XLT model version A from now through infinity, right? So again, if I create a model version B, this one, I might say that the effectivity of this to model version XLT B, not A. So then it would only show up if I'm in the context of XLTA. Okay. So now I've got my product definition created. And if I go over my engineering tab, I have my trim packages, right? Look, there's my ST line trim. Okay. So I'm going to go ahead and select refresh, just so we can make sure that that wasn't there from a holdover. My trim package, there's ST line. Now, just so you understand, is that this trim package that's inserted under here is the exact same object that is here. So if I renamed this one, if I change the name here, to ST line super trim, just for demonstration. And if I come over to my engineering definition, you'll see it updated here as well. So the object structure, this trim package structure, is the same as what was defined in my product structure. Okay, so there's no real magic. It's just that I've added a component, I added a child here. Each child shows up under my engineering definition as well. Okay, so now, how do I apply the configuration that I created over here? So remember, I created a configuration, ST line for 5.4 rear-wheel drive premium. So let's look at my engineering definition, and let's take and choose my model version, and I'm going to select the XLT. Okay. Okay. Right, and because right now, it has both engines, right? It has all the tech, and it has all the trim packages. So this is my 150% bill of materials, right? So how do I filter this down? So now that I have a product configuration, I'll select that, and I'm going to say the ST line premium, okay? And I click OK. Now I'm going to go ahead and select everything, and I'm going to say expand all. And now look, because I applied the configuration that was defined in variants and options and model versions and configurations, now my engineering definition is filtered down to the 100% bill of materials, right? So now under manufacturing, I'm going to say new session. I'm going to come over to engineering, and I'm going to drag and drop this from here to manufacturing. Because this is my engineering screen where I can look at my engineering definition and then build a manufacturing definition from there. So again, now, since I drag and dropped it from the product, from the engineering definition, brought it over, it brought over the 150% bill of materials. The 150% engineering definition is showing up here. Okay, so again, I don't want to manufacture from it. So what do? I come over to here. I select my filter. I select my configuration. And I say apply. Now if I come over here and say expand all, look, I've got a rear wheel drive, 5.4 liter. I've got the premium sound system, Wi-Fi, trim package, ST line. So now as manufacturing, I have to consume these objects, right? So now if I come over to authoring and I say create a manufacturing assembly scope link from XLT, I'm going to say save as in work, and it's going to create a scope link from the XLT into manufacturing definition. The only thing I have here is the top level, right? So I've got a scope link between my manufacturing assembly and this top level. I could have done it at the engine or tech. If I only wanted to build the tech, I could have just done that, or planned for that. But I'm going to plan for the entire structure for right now. So I'm going to go ahead and come over here and say create new assembly, manufacturing assembly, and I'm going to call it drivetrain. Okay, and I'm going to call it MFG drivetrain. Okay, just so that we see that it's different. Now, what I want to do is I want to consume certain points, certain parts of this into this structure. So I want the rear differential only. Let's see. I want the drive shaft and the U-bolts. Bring these over and put it into the drive shaft. Now I want to come over here to the XLT, and I'm going to say new So I'm going to come over to the XLT again, and I'm going to create another manufacturing assembly, and I'll call it rear axle. Now in the rear axle, I'm going to consume the rear differential. So let's take a second and see what that looks like. I'm going to come over to my view, authoring, tools, and I'm going to look at my BI Essentials assignment status. So right now I see what on the engineering side has been consumed on the manufacturing side. So if I look at this side here, I see that the top level associated with scope partially assigned. So the drivetrain part is partially assigned to here because I've left out this node. Okay, so I don't care about the rear wheel drive object. What I care about is the differentials and things like that. Okay, so I want to take and I'm going to adjust my view. You see there's a scope link from the drive shaft to this drive shaft, from this U-joints to those U-joints. So now I could come in here and say XLT, let's go ahead and create a kit, and let's call it a manufacturing kit, and let's call it infotainment, right? And that infotainment is going to contain a few different options, right? And they're all going to be bought, let's say, right? So, or whatever reason. So I'm going to come over here and say Wi-Fi antenna, the GPS, and the premium sound system. I'm going to bring all that over, and I'm going to drop it into this kit. maybe I buy it or whatever else, or I build it some other way and I bring it into my manufacturing BOM as a kit. So now again, this is telling me what's consumed and what's not consumed. I'm going to select this. I'm going to say new, create manufacturing assembly, and I'm going to call it trim package. In that trim package, I want to consume the ST line trim package. I have to drop it in the right spot. There. And now I see it here. So now let's take a look at our BI Essentials again. And let's see what was consumed and what's not. So here I've consumed everything. So now let's go under trim package here on the ST line. Let's go ahead and add in create manufacturing material. And we're going to call it sticky tape. Okay. Now this is a manufacturing object. It's consumable or something like that. So I'm not too worried about it. It won't show up over here. Okay. So now you can see, and this is probably good enough for the demonstration purposes of how the 𝑚BOM and the eBOM, the 100% configuration of the eBOM is available, or how it links and drives the 100% or the manufacturing bill of materials. Sorry about that. Trying to switch screens.
All right. You good, Kip?
Yeah, there we go. So sorry, I had to get myself off mute. So I hope you enjoyed that presentation of eBOM to 𝑚BOM and the added bonus at the end towards how to create product configurations and consume those into the engineering BOM, into the 100% BOM, and a build your manufacturing BOM. So how can Razorleaf help you? We can helping you in your PLM journey, aligning current business processes to meet your definition of UPS or 3DEXPERIENCE, your product definition journey, digital thread, support with existing systems, and we can help you with product management. From there, I'll go and open it up for questions.
All right, well, thank you, Kip, for that very informative presentation. We have a few questions here. The first one, is it possible to filter the eBOM without using the product architect role?
It is. It's a little bit more difficult. It takes a few more steps, but you can actually create filters in the engineering definition or the XEN application based on selections. So you could create a filter and then create select which items belong to that filter. So it's not as effective, but it is possible to do without the PAU or the product architect role.
Okay, great, thank you. Here's another one. When there are revisions to engineering items, is there an indicator in the 𝑚BOM?
Yeah, and I kind of pointed to a little bit in between the engineering screen and the manufacturing screen in the MFN or the manufacturing item. You'll see that the dot in the BI Essentials, you'll see a dot that has a red icon to it to indicate that it's not the latest revision.
Okay, and if anyone has any additional questions, please just drop them right in the chat box. And it looks like I have one more, Kip. Can you create multiple 𝑚BOMs against an engineering BOM?
Yeah, so you may have multiple plants that you're gonna do a production at, right? So this is where plant specific comes in. So you may end up doing multiple 𝑚BOMs from an engineering 100% BOM based on a specific plant. So it is possible that you can do it. It just takes a little bit more planning and structure and things like that.
Okay. All right, and that wraps up the questions. So I appreciate the questions that were sent in. And again, we will be sending out this recording in the next day or so. And Kip, do you have any closing items?
No, thank you very much. And I really appreciate everybody joining.
Great. Thank you, everyone. Have a great day. Bye-bye.